Hi everyone, today we will see a very beautiful problem, or we can say very beautiful relation that we have to establish. Because why it is so important? Because it has lot of application in various problems. Okay, so further lectures we will see the usefulness and application of these results. So we'll see what are the results. So first result is that, so that f of s means fs means Fourier sine transform of x f of x equal to minus d by dw of Fourier cosine transform. Okay, similarly Fourier cosine transform of x f of x will be d by dw of Fourier sine transform of w. Okay, so these are two relations which will be very useful. So we'll start with the first relation. We have to prove it whether it is correct or not. So first relation we are going to prove. So f s x f of x. Now what to do? So we'll start with the RHS. Now in RHS we have FC. So FC of w. So FC of w is what? So this is the Fourier cosine transform of this function f of x. Now this will be square root of 2 by pi 0 to infinity integration f of x cos wx dx. Okay, now but here what we have, d by dw. So if I take d by dw of f of c, so then what will happen? It will be square root of 2 by pi integration from 0 to infinity, as we are differentiating with respect to w. So f of x remains same. Here now we have to apply. So d by dw of cos wx, because cos wx involve w, into dx. So this will be what? Square root of 2 by pi, okay, integration from 0 to infinity f of x. Now d by dw of cos wx. So derivative of cos wx is what? Minus sin wx whole into what? Chain rule you have to apply. So derivative of wx will be x, because we are differentiating with respect to w, into dx. So now here we can write it again as 2 by pi times, means square root of 2 by pi times 0 to infinity integration x f of x, okay, into sin wx dx, yes or no, and the minus sign will write here. Okay, now if you see this one, so what will happen? So this one is minus of this square root of 2 by pi integration from 0 to infinity x f of x sin wx dx. But what is the formula? This one, if we take x fx as one function, okay, then what will be the formula? So this will be minus of Fourier sine, okay, transform of what? X f of x. So here we got the LHS, yes or no? So it is now proved. So the relation, first relation is correct. Okay, that means what we can write? Fs x f of x will be minus d by dw fc w. This one now correct. Similarly, we will prove second one. So second one also will start from the RHS. So RHS we have fsw. So fsw is what? Square root of 2 by pi 0 to infinity, then f of x, what? Sin wx dx. Now what we will do? We will take the derivative with respect to w. So d by dw fs of w will be what? Square root of 2 by pi integration 0 to infinity f of x d by dw of sin wx dx. Now what will happen then? Square root of 2 by pi into 0 to infinity. Now this is f of x, sine wx will be what? Derivative of sine wx with respect to w will be x cos wx. So we will write wx here, x will be in left side. So this expression. Now again if you see x fx as one function, then that function into cos wx dx. So it will be in the form of Fourier cosine. So what we will write? So this will be Fourier cosine of what? X f of x. So Fourier cosine transform of this. So from this we can get the relation. So what is the relation? Fourier cosine of x f of x. Okay, this equal to what? D by dw of Fourier, sorry, here, yeah, it's correct, d by dw of this Fourier sine transform. So in this way we can prove these two beautiful relation. Next we will see the application of this relation in terms of one example problem.